Hey everybody, welcome to CPM 3. We are beginning Module 3, so this is the first lesson. As you can see, we're covering a lot of different sections. I want to say this lecture is like 8 pages long. So this will be split into 2 different lessons, and depending on what class you're with and who the instructor was, the first instructor is going to get as far as they can through this lesson. And then the second instructor is just going to pick it up wherever the first one left off and finish it. So it could be split in a different spot for every class. But this is a 2 lecture lesson. And so that is why this is so long. We're going to be going over a lot of different things and sort of jumping around quite a bit. But the first thing that we have to do is define what a polynomial is. And so here's your definition of a polynomial. It says it's an infinite sum of terms in the form of ax to the nth power, where a is a real number and n is a whole number. So what does that mean? It's going to look something like this right here. You're going to have all of these different terms adding and subtracting with each other. And as you can kind of see, these exponents go down. You got the 5th power, then it's cubed, squared, no power, and then no exponent. So it always kind of decreases, and that's what it says right here in descending powers. Now there are different types of polynomials. You've got a monomial, binomial, trinomial. And then I guess if it's anything other than it's just considered a polynomial. Your monomial has exactly 1 term in it. So for example, that would be something like 3x to the 4th power. Okay, it's basically just 1 term. So then a binomial, bi means 2, has exactly 2 terms. So that could be something like 3x to the 4th, maybe plus 2x. Okay, you've got the 2 different terms, the first term, the second term. And then trinomial, tri means 3, like a tricycle. So that means it's got 3 terms. So something like 3x to the 4th plus 2x, and then maybe minus 5. You've got 3 different terms there. Now, our homework used to have something about finding the degree of each term. Honestly, though, you don't have any homework over it, and this portion seems to confuse a lot of people. So we're just going to skip that, okay? So let's just go to the next page. You won't have any homework, no test questions, anything over that. So the first thing that we're actually going to do then is find simply the degree of the polynomial. The degree of the polynomial is the greatest degree of any term in the polynomial. Okay, greatest degree. So in other words, whatever the highest exponent is. So example 2 says find the degree of each polynomial and tell whether the polynomial is a monomial, binomial, trinomial, or none of the above. So basically if it has 4 or more terms, it's none of the above. So in this first one, you're looking for the highest exponent. You've got an exponent of 2 here. If you don't see an exponent, that's a 1. And then if you don't have a variable, that's no exponent whatsoever. So what's your highest exponent? That's going to be a 2. And then is this a monomial, binomial, or trinomial? Well, it's got 1, 2, 3 terms. So since it has 3 different terms, that makes this one a trinomial. Okay, on B, what's the degree of this polynomial? Well, if you don't see an excuse me, if you don't see an exponent, there's a known 1 there. You don't see any variable at all, so there's not 1 there. So this one has a degree of 1. And because this one has 1, 2 terms, that makes this one a binomial. Okay, now this one's not in descending order, but still. We've got 7x to the first, if we don't see that exponent. We've got a cubed a squared, and then no variable. So what's the highest exponent? That's this 3 here. So my degree is 3. And is this one monomial, binomial, trinomial, or none of the above? This one is a none of the above. Okay, example 3. This is a Swiss building in London, often referred to the Pickle building. Is this many feet tall. The object is dropped from the highest point of this building, neglecting air resistance. The height in feet of the object above ground at the time t seconds. So t seconds is given by the polynomial function of this right here. Find the height of the object when t equals 1 second and when t equals 6 seconds. So all of that, all I care about here is that my t equals seconds, and that I want to find when t is 1 and when t is 6, and we're using this function right here. Okay, the rest of this does not even matter. So this is kind of 2 in 1. First, I want to find when t is 1. So all we're doing is taking this function here and plugging in a 1 for that t. So now we've got negative 16 times 1 squared plus 592.1. Now, you can do this step by step. If you do it step by step, everybody seems to want to multiply here first. You're not multiplying first, right? If you use your please excuse my dear Aunt Sally or PEMDAS, you got to use exponents first. So you're doing 1 squared, then multiplying, then adding. But there's really no reason to do this one step by step. Simply put this in your calculator exactly the way it looks. When you do that, we get 576.1 feet. Okay, and I know I'm in feet because we have feet right here. And what are we finding here? We have found the height. Okay, so my h equals 576.1 feet. And so that is my answer here. Okay, same thing for my second part. Now I need to know when t is 6. So after 6 seconds, what's the height? So plug it in. We've got 16 now times 6, since that's my t, squared, plus 592.1. Same thing, if you're doing this step by step, you've got to do exponents first, then multiply, then add. But again, this is calculator work. There's no reason we need to do this step by step. So you put that all in your calculator and you'll get a height of 16.1. Units are important, feet. Okay, so that's all you're doing on that. You're going to have one question like that on my math lab. Okay, the next objective, I told you we're going to be kind of bouncing around everywhere in this lesson. We've got so many like little parts to do. Second part is to add and subtract. And so before we get into adding and subtracting, we got to remember what your like terms are. You have some examples of like terms here and of unlike terms here. The big thing is, because now we're not just dealing with like x and y, we're dealing with exponents too. For these to be the same term, for them to be like terms, it says terms that contain exactly the same variable raised to exactly the same power. It's got to be both. So you can see here, like in this one here, a lot of people want to combine ones like these. But here you have an x squared. Here you just have an x. So you can't combine those because they're different powers. So not only do they have to be both the same variable, both the same letter, but they also to the same power. So here when we're adding, don't worry about the parentheses, okay? Just combine your like terms. what can I combine with this 7x cubed y? That would be this 6x cubed and y. So 7 plus 6 gives me 13. When you're adding and subtracting, you do nothing with those variables. So this stays x cubed y. Okay, not x to the 6th, because that's multiplying, right? When you multiply exponents, you add them. I'm not multiplying, I'm just combining. So it stays the same exponent. Okay, so then we have this one here. A negative xy cubed, because that cubed is on something else. Right here you have a cubed x, but on this one we have a cubed y. I can't combine to anything with that one, so because there's nothing else with that same variable, it just comes down. So minus xy cubed, and now combine just your numbers. We've got 11 minus 4 to get a plus 7. And so now nothing else is a like term, so I can't do anything further with this problem. So that is it. Okay, same thing on B. We have an 11x cubed. What can I combine with 11x cubed? This x cubed. So what's the number in front? That's a 1, right? That's a 1x cubed. So 11 plus 1 gives me 12x cubed. Again, we're not combining those variables. We're not combining those exponents, right? It stays x cubed. So then I go to this x squared. I don't have any other x squared, so it just comes down. So minus 12x squared. Okay, then we have an x, and we have a minus 10x. So again, 1 minus 10 gives me a negative 9. That variable stays, so it just stays x. And then we've got a negative 3 plus 5 to get a positive 2. Okay, and again, I can't combine to anything here because yes, I have some with x's, but they're all different exponents, so that's as simple as that gets. Now, subtracting is almost the same thing, but you have one additional step. It says to subtract two polynomials, change the sign of the polynomial being subtracted and then add. So I need to change this to an addition problem. The reason I didn't have to worry about those parentheses in the top one is if you think of this having a 1 in front, when you do 1 times anything, does it change anything? No. So I'm just going to take this first one here and just rewrite it. I've got 2x cubed plus 8x squared minus 6. But now that this is a minus here and not a plus, now you've got to think of this as a negative 1. When I distribute this negative 1 to everything, now it changes the sign, right? And so that's what they mean by change the sign of the term being subtracted. So negative 1 times 2 is a minus 2. So now we got minus 2x cubed. Negative 1 times negative 1 is positive, so I got plus x squared. And negative times positive makes this a minus 1. So we literally just changed all of the signs in that second one. That positive 2x cubed became a negative. That negative x squared becomes a plus x squared, and that plus 1 became a minus 1. Now I just combined everything the way that we had before. So now 2x cubed minus 2x cubed. Well, 2 minus 2 is 0. So now those are just gone. We have no more x cubes. So now we got an 8x squared plus x squared. 8 plus that 1 makes that 9x squared. And then we have -6 minus 1 to get a -7. Okay, let's try again here. Now on this one, same thing. All you're doing is distributing that negative, and if you want to make that a -1, you can. So that -5x comes down. And now negative times negative makes that a plus 7x cubed. Negative times negative makes this a plus 15x. And negative times positive makes us a -2. You're just changing every sign. This was negative, negative, positive. Now it's positive, positive, negative. So now combined. I always like to start with the highest exponent first. So I'm going to start with this one here. There's nothing to combine with it. So it just comes down, 7x cubed. Now I have a -5x plus 15x to get plus 10x. And then this -2 just comes down. Okay, example 6, we're finding the perimeter. When you find the perimeter of anything, you are just adding all sides. So by them telling you to find the perimeter, they're basically wanting you to combine like terms. Okay, so we don't have a lot of room to write, so I'm just going to circle the same and box the same way we did like right up here. So what are my like terms? We've got 5x, 7x, 4x, 2x, and 3x. So just add up 5, 4, 2, 7, 3, and we're going to get 21x. And now add up all of these numbers that don't have variables. 3, 3, and 6, that's going to give me a plus 12. Now, usually with perimeter, you need some kind of units, but because I don't have feet, inches, or anything, I'm just going to put UN for units. Okay, so my perimeter is 21x plus 12. Example 7, perform the indicated operation. So if you notice between these two here, it's almost the exact same thing. You have a 4x squared, you have a y squared, you have a minus in between them. The difference is this one has parentheses in this one and B doesn't. So what do these parentheses indicate that I am doing here? Well, that one means I'm multiplying, right? So multiply. 4 times -1 is -4. And then y squared times y squared, when you multiply, you add your exponents. So 2 plus 2 makes this one y to the 4th. Now on B, when I take away those parentheses, now what am I doing? Okay, in class, a lot of people usually either says combining like terms or subtracting. Okay, either of those are correct. We are combining like terms because they are like terms, right? They both have the same variable and they both have the same power. So if this is a 1 in front, 4 minus 1 is 3, and then keep the same like term so this stays y squared. So see, explain the difference between A and B. A, we're multiplying. And on B, we're subtracting. Okay, so you do need to know the difference between when you are doing what. All right, now we're going to use distributive property. And we've done distributive property before. We just haven't done it with so many exponents and stuff, but it's still the same thing. Whatever's on the outside of this, you are making it rain to everything on the inside. So 5 times 2 gives me 10, and then x times x cubed, when you multiply, add your exponents, so that becomes x to the 4th. That's a bad 4. Okay. So then here, this one we're used to, 5x times 6, 5 times 6 is 30, and then keep your x. Okay, on B, same thing. You're going to take that one on the outside and distribute it to everything on the inside. So negative 3 times 5 is negative 15. And then x squared times x squared, when you multiply, add your exponents, so it becomes x to the 4th. Negative 3 times 6 is negative 18. And x squared times x is x cubed, right? 2 plus 1. And then negative 3 times negative 1 is a positive 1. Is a positive 3. And then keep your x squared since there's no x to combine it with. So we've done that one before. Okay, the exponent rules, those are from last module. So now we need to multiply two polynomials together. More specifically, two binomials together. So I'm going to show you both of these ways. Here it says to multiply each term of the first polynomial by each term of the second polynomial, then combine like terms. Okay, so this is your option 1. So if you notice, these two right here are the same. We're going to do the same problem in two different ways. So if I use my option 1 here, this is what it means. Multiply each term of the first polynomial by each term in the second. We're going to make it kind of set up as a double distributive property. I'm going to take this first term here, 3x, and multiply it by this whole binomial. I'm going to scoot this over some. Okay, so I took this term here, that's right there, and I'm multiplying it by this whole term right here, that whole binomial. So then you have to do it as well to this plus 2 here. So I'm going to do plus 2 and multiply it by this same binomial. Okay, so I did the same thing, that plus 2 and then this whole binomial. So if you notice, you've got that second binomial twice. So now just distribute and combine. You've got 3x times 2x to get 6x squared. 3x times a negative 5 to get negative 15x. Then distribute your 2. So 2 times 2x gives me plus 4x. And plus 2 times a negative 5 makes that a negative 10. And then combine your like terms. So here, my like terms to combine are these middle ones. So my 6x squared drops down. Negative 15 plus 4 is a negative 11. And then drop down your minus 10. So this is my final answer. Okay, so that's the first option. Second option, I'll go ahead and use a different color. Second option is to use this special method that only applies to binomials, which is called FOIL. And so you kind of see what it means right here. But your FOIL stands for your first terms. Okay, so You can use this if you want. I'm going to go ahead and just use this on this one here. So your first terms are the first two numbers in each binomial, right? It's the terms to the very left of each binomial. So I'm going to do 3x squared times 2x, which gives me 6x squared, okay, which we got right here. O stands for outer. Okay, your outer ones are the ones on the outside. So your 3x and your -5 are the two on the very outside of both of these binomials. So we'll do 3x times -5, which is -15x, which we got right here. Okay, that was this right here, which if you notice, I'm just taking that 3x and distributing it to both of those terms in that second one, right? Okay, your I stands for inner. So your inner ones here are these two middle terms. So 2 times 2x is going to give me 4x, which we got right here. And then L stands for last. So this end one and this end one multiply together. So 2 times -5, which was -10, which we got right here. So if you notice, what we have right here is exactly what I had here. So now, just like before, combine your like terms. So you got 6x squared minus 11x minus 10. So you get the same answer no matter what, and if you notice, you're kind of doing the same thing, right? Here you're distributing the 3x and then distributing the 2. We did the same thing. We distributed the 3x and then we distributed the 2. Okay, so it just depends which one you like. So this was your second option here. I'm going to show you another way to do this as well. There's actually a third option that I'll show on this one. And notice these again are the same. So one other way to do this is, because you're doing a binomial times a binomial, is to make a 2 by 2 square. So 2 by 2 square. Now, so for example, if you were doing like, you won't, but if you were doing a binomial times like a trinomial, you would do a 2 by 3 rectangle. You want that to always match the dimensions of what you're multiplying. So it doesn't matter which one you put where. I'm going to put this first one here on the side. So I've got 5x, and then keep that sign with it, minus 2. Then this one will go on the top, so 2x, and then a positive 3. And so if you switch them, it doesn't matter. You just need one on the side, one on the top. And now multiply within each square. So for example, in this one, we're doing 5x times 2x. So we get 10x squared. Then we'll do 5x times 3 to get 15x. Negative 2 times 2x to get negative 4x. And then negative 2 times 3 to get a negative 6. And then combine your like terms. Here, your like terms will always be diagonal from each other. So I'm going to get, I don't know where to write this. I'm going to get 10x squared from here negative, or 15 minus 4 gives me a plus 11x, and then keep your minus 6. Okay, that's another way to do it. But what we really and truly need to get good at, and that's what we'll do from here on out, is our FOIL. So, first, outer, inner, last. So here my first is 5x times 2x. So we're going to get 10x squared, which we got right here. My O is outer, so 5x times 3, so plus 15x. My inner, negative 2 times 2x to get a minus 4x, which we got that here and here. And then negative 2 times 3 for my last, which is negative 6, which we got right here. So just like before, combine your like terms. So my final answer is 10x squared plus 11x minus 6. Okay, and we need to get good at that FOIL. So I'm going to do the rest of them using that FOIL method. But if you like this way, you can use this way. And if you like this way, you can use that method. Okay, it doesn't really matter what you use, you're going to get the same result. But like I said, we need to get good at FOIL. So here, when we're multiplying on 11, what is everybody's kind of first instinct is just to distribute that square to everything, but that's not what we're doing here. Because this whole thing is your base, that means you have 2 of that base. So that means I have 2x plus 4 times 2x plus 4, and now we get to FOIL. So my first 2x times 2x is 4x squared. My outer 2x times 4 is a plus 8x. Inner 4 times 2x is a plus 8x. And then my last 4 times 4 gives me a plus 16. And now just combine your like terms, which are right here in the middle. And so we get 4x squared plus 16x plus 16. Okay, but you do have to expand this before you multiply these out. So if you'd like to, if you're starting to feel more comfortable with this, try and pause the video and see if you can do BL by yourself. All right, so hopefully you pause that video and you tried it, but we're going to expand this out first. So you got 5x minus 3 times 5x minus 3. So my first is 5x times 5x. My outer, my inner, and my last. Then hopefully you combined it, these like terms here, so your final answer was 25x squared minus 30x plus 9. Okay. Now, you don't really need to know the name, but these types will come up again. When you have the same thing and you have like that quantity squared and you have to expand it before you FOIL, these do have a special name. These are called your perfect square trinomials. These will come up again in your next lesson. Okay, whenever it looks like this right there. So just going to kind of plant that seed so that hopefully that will come back up in your next lesson. Okay, 12, find the area of the rectangle. Include units, even if it doesn't say that, we are. So this, excuse me, to find the area of a rectangle, we use length times width. So here, doesn't technically matter, but your length is the longer one. So 2x plus 5. And then your width is the shorter one, which is 2x minus 5. And so just like on that previous one where it told us to find the perimeter, it's just a fancy way for us to combine like terms. This one just happens to be a fancy way to get us to FOIL, to get us to multiply these two binomials together. So multiply. Your first here, we've got 2x times 2x, so we're going to get 4x squared. 2x times a negative 5. 5 times 2x. And 5 times a negative 5. So now when I combine my like terms, here in the middle, what happens on this one? Well, negative 10 plus 10, that zeroes out, those cancel. And so now, my final answer, my area, is just 4x squared minus 25. Okay, we don't have that middle term anymore. It's just this. So, then we need to include our units. We're in unit of yards. And because I'm finding area, it's yards squared. So this is my final answer. Now be careful from here on out that, like on this one here, when I had negative 15 minus 15, you can combine those, right? That becomes that negative 30. Or like on this one, 8 plus 8, that can combine to a positive 16. The reason this one cancels each other out and goes away is because you have one positive, one negative, right? We had negative 10 and then a positive 10, so they canceled out. But if they have the same signs, don't cancel those out, and that's what will be a common mistake from that. And just like this one has a unique name for it, your perfect square trinomials, this one here does too. This is called your difference of squares. And when you have a difference of squares, if you look right here, unlike this one, that's like this is the same, so we combine it to be 2x plus 4 quantity squared. You can't combine this one because it's almost the exact same, but one's a plus 5, one's a minus 5. When it's the same thing, but the signs are different, that's your difference of squares, and every single time, that's when your middle guy will cancel out. Okay, so just so you guys are aware of that. And then our last example on this page is to find the area of a triangle. And so here is the formula for area of a triangle. However, I know a lot of people don't like this 1/2 here. So instead of having your area formula as 1/2 base times height, you can rewrite that to become base times height divided by 2. And it seems like a lot of people prefer the second way. So I'm going to use the second way just because for the most part people seem to like that one more. You can also change this to a 0.5 if you would like to as well, okay? But if I use the second one, my base is this one here. So I've got 3x minus 2 times my height of 4x, and this is all over 2. Now, we don't see distributive property like this very often, but this is distributive property. Even though that 4x is in the back instead of in the front, you're still distributing that to everything. So 3x times 4x is 12x squared. Negative 2 times 4x is a minus 8x. And this is all over 2. Now be careful here. What is getting divided by 2? The 12 or the negative 8? Trick question. Hopefully you said both. Okay, everything's getting divided by negative 2. So 12 divided by 2 is 6x squared. Negative 8 divided by 2 gives me a minus 4x. And again, it says to include units, but even if it didn't, we are well practiced and we will. So we're in unit of inches. And because I am finding area, area is always your units squared. Okay, so that's my final answer there. Okay. And we're going to keep on going. So, turn the page, 14. It says, write a polynomial that describes the shaded region. And then you have a hint. It says, find the area of the larger square minus the area of the smaller square. You're not going to have one this hard on your test or anything. I simply added this one because you're going to have a My Math Lab question that's very similar, okay, to this problem here. Okay, so the first thing you need to do is find the area of this square here as if that one chunk wasn't missing from it. So, to find the area of a square or a rectangle, we can use the formula length times width. So, because they're the same, it doesn't matter what, my length times my width. So we've got x plus 3 times x plus 3. I don't know if you're tired of foiling or not yet, but that's what we're doing here. So your first your outer, your inner, and your last. Okay, then combine your like terms. Do these cancel out? Hopefully you said no. They're the same sign, so they don't cancel each other out. So this is x squared plus 6x plus 9. Okay, we're not done yet. This is the area of the square as if this chunk right here was not missing. So let's find the area of that chunk there. So the area of that is still length times width, which is the same thing. Length times width, or vice versa. Either way, you're doing 2 times 2. So we get an area of 4 for that chunk that's gone. So now combined. So now that I have found that this area here is 4, the area of the whole thing is this, subtract them apart from each other. So now I've got x squared plus 6x plus 9, and now I'm going to take away this 4 here. I'm going to take away what's missing. So combine your like terms, and my final answer here is x squared plus 6x plus 5. Okay, and again, you don't have any units here, but that bugs me, so I'm going to put a little u in so I know whatever it is, it's that unit. And because this is area, it's not just units, but it is units squared. Okay. Okay. For the rest of this lesson here, we're now doing everything that we just did and almost in reverse. And so you kind of have some information right here about what we're doing, about the factored form. Your next lesson, you're going to be going from like, instead of having this right here and foiling it to then get to this as your answer, you're going to start here and have to factor it to what it was before you foil. Okay. But before we can do that, we need to go over what's called the GCF. So let's just go ahead and turn the page and go over this stuff here. Okay, this will all kind of go together at the end, but it'll really go together next lesson. Okay. Excuse me. It says the first step in factoring a polynomial is to see whether the terms of the polynomial have a common factor. If there is one, we factor out the biggest number of the term they have in common, which is called the greatest common factor, or you'll only see it abbreviated as this GCF. If there are no common factors, the greatest common factor is 1. I'm going to show you 2 different ways to do this. Okay. The first way was the way I was taught when I was in school, and it's a tedious process. Okay. Take 16 and 6. I'm going to just take that 16 for a second and write all of its factors. So you always start with 1. You've got 1 times 16 get you 16. So then go to 2. Can you divide into 2? Yes. 2 times what? 2 times 8. Okay, I notice I'm kind of going back and forth so that these will all be in order at the end. So then go to 3. Can you divide into 3? No. How about a 4? Yes. 4 times 4. And then you keep going. Can you divide into 5? No. A 6? No. 7? No. And then now we're back to an 8. So I know I've got them all. Do the same thing with 6. Okay, 6, you got 1 times 6. So we start with 1 times its number. Can you divide into 2? Yes. 2 times 3. And so then no 4, no 5, you're back to 6. So my GCF here, what is the greatest number that these have in common with? Its greatest common factor would be this 2 here. 6 doesn't have a 4 or an 8 or a 16. 16 doesn't have a 3 or a 6. So the greatest one that they share is that 2. So my GCF here is 2. Okay, now that's one method. Now this one's not so bad because we have 16 and 6, right? But what happens if I have like 40? 40 has a bunch of different multiples and you don't want to list them all out. Same with numbers like 66. So when that's the case, we'll do this method called an upside down birthday cake. So take 18 and 24, and we're going to put like a little bracket around them. So find a number that divides into them. It can be the biggest number, it can be a small number, it can be any number, it doesn't really matter. Now, if you actually can see 18 and 24 and you know that your GCF is 6, you don't need to go through this process, okay? But let's say we don't know it's 6. But I can see that these are both even numbers, okay? 18 and 24 are both even. So I know I can divide in a 2. So divide them both by 2. 18 divided by 2 is 9. 24 divided by 2 is 12. So you look at these numbers. Is there anything I can divide into these again? Yes, these are both multiples of 3. So we'll divide into 3. So 9 divided by 3 is 3. 12 divided by 3 is 4. Can you divide anything else into 3 and 4? No. So then to get your You just take these numbers that we divided out and multiply them back together. So now 2 times 3 gives me 6 for my GCF. Okay. Same thing on C. Hopefully when you look at that, you can see what your GCF is. But a lot of people say 10. Well, let's look if 10 is the GCF. I've got 40 and 20. If we divide in 10, which 10 can be broken up, right? You could say 2 and 5 and eventually get to that 10. But if we start with 10, 40 divided by 10 is 4. 20 divided by 10 is 2. Can I divide anything into 4 and 2? Yeah, those are still even, so I can divide in a 2. 4 divided by 2 is 2. 2 divided by 2 is 1. When you get to a 1, there's nothing else you can do. So take these two numbers, multiply them back together. My GCF on this one is 20. And so sometimes your GCF is one of your numbers. Okay, on D, we got 28 and 40. Now, a lot of people say that 2 is the GCF on this one when they first look at it. And that's why I love this method of your upside down birthday cake, because it's a great way to check. If you've got 28 and 40, and we say 2. 28 divided by 2 is 14. 40 divided by 2 is 20. These are still even, so I can divide in another 2. 14 divided by 2 is 7. 20 divided by 2 is 10. I can't divide anything into 7 and 10. So let's multiply these back together, and my GCF is not 2. It is actually 4. Okay, so it's a quick and easy way to check to make sure your GCF is correct. Now in E, if you kind of go with the upside down birthday cake, you look at 55 and 21, you're like, I don't really know a number that I can divide into both. So I'm going to go back to this method right here, actually. 55 is 1 times 55. Can't divide in a 2, 3, or 4, but I can do 5 times 11, and then I can't do 6, 7, 8, 9, or 10, and then I'm back at the 11. 21, you got 1 times 21. Can't divide in 2, but I can divide in a 3, which is 7. Can't divide in a 4, 5, or 6. So here, my GCF, what's the greatest common number they both have in common, is just this 1. So if you can't divide any of them by a number, 1 is still technically that common factor. Okay, and so that's why I underlined this right up here. If there are no common factors, the greatest common factor is 1. So you'll always have an answer for that, for whatever your GCF is. And then for F, honestly, hopefully you can see what your GCF is between 15, 18, and 66, but I wanted to show you that this upside down birthday cake works even when you have 3 different numbers. Okay, so find a number you can divide into all of them. They are all multiples of 3. So divide. 15 divided by 3 is 5. 18 divided by 3 is 6. 66 divided by 3 is 22. Can you divide 5, 6, and 22 by another number? No, you can't. So my GCF is 3. Okay, so the upside down birthday cake works with however many numbers you have. Okay, so that's how we find the GCF with a list of numbers. So now let's go to a list of terms. When I have a list of terms, it says here, the greatest common factor of a list of terms raised to powers is found in a similar way. The GCF is the list of common variables. Raised to powers is the variable raised to the smallest exponent in the list. Okay, always, always, always just look at your list. What has the smallest exponent? That's your GCF. So here, x cubed, x to the 7th, x to the 5th. What is the smallest exponent? That x cubed. That's it. B, y cubed, y to the 7th. What's the smallest exponent? Well, it's that 1 right there. So my GCF out of that list is just the y. On C, you have multiple variables. Just do one by one. What's the smallest out of m squared and m? That is the m. What's the smallest exponent out of the n squared and n to the 4th? That would be n to the 4th. Okay, smallest exponent. So now let's put both of these together. Now we're going to have a list of terms that have both numbers and variables that we need to find a GCF for. Okay, and again, remember it's the smallest exponent every single time. So here, look at the number in the front. We have 6, 10, and a -8. Now, don't really worry about the negative right now. Okay, we don't really care about the signs. Just what can I divide into 6, 10, and -8? That is a 2. Okay, and if you need to, you can come over here and do your upside down birthday cake. Divide into 2, that gives me 3, 5, and 4. I can't divide anything else in there. Okay, so we get 2. And then what's the smallest exponent? We got cubed, squared, and just an x. Just that x is my smallest one. So this is my final answer. Okay, same thing here. We've got -18, -63, and 27. Again, don't worry about the negatives right now. What can I divide into 18, 63, and 27? A lot of people say 3. So if we go with the 3, let's just see if that's the biggest one. Okay, divided into 3, we get 9, we get 21, and, oh, crap. Let's try a 6 here, shall we? 18 divided by 3 is 6, not 9. But then 21, and now 9. Those are still multiples of 3. We get 3. I'm struggling on that first one. We get 2, 7, and 3. And now I can't divide anything else. So my GCF out of those numbers is 9. And then what's the smallest exponent? We got squared, cubed, and 4th. Squared is the smallest. Okay, and then last one here. What can we divide into 5, 7, and 15? Well, because 5 and 7 are both prime, I can't divide anything into those numbers. Okay, so we can put a 1 there, but I'm not going to. Okay, but you can't divide anything into the numbers. So now just look at the variables. We got a cubed, a to the 5th, a to the 6th. What's the smallest one? Is that a cubed? And then we have a b squared, a b, and a b squared. What's the smallest one? That is the b. So we got a cubed b. And the reason I didn't put the 1 is because I knew we had other stuff. But if you had a 1a cubed b, that would be the same thing. Okay. Last example. And this is kind of what we've been doing all of this for, to be honest with you. The last three examples, it just told us to find the GCF. Now, it is actually telling me to factor out the GCF. What we are doing here is distributing backwards. So for example, if you have something like 2 times 3x plus 4, you do 2 times 3x to get 6x and 2 times 4 to get 8. I am now starting here and I need to get to here. Okay, we're going backwards. So it's going to be just like this, but with one extra step. Now I got to divide everything out, whatever that GCF is. So for example, in A, what can I divide into 6 and 18? That's going to be 6, right? That's that GCF. That's the biggest one I can divide out. I can't take out a variable because yes, we have a t here, but this one doesn't have a t. Okay, so I'm not taking out any variables. So once I figure out what my GCF is, now I need to divide it out and say what is left in parentheses. So 6t divided by 6, my 6's cancel, we're left with a t. And then negative 18 divided by 6 is a negative 3. So this is my final answer. These are so easy to check. Okay, I'm gonna have to rewrite this. That line's gonna bug me. I'm sorry, guys. Don't know how that line got there, but I couldn't handle it. Okay. These are really easy to check. Distribute back. Do I get to my original problem? 6 times t is 6t. 6 times negative 3 is negative 18. Yep. That distributes in correctly. So these are super easy to check. Distribute back. Do we get to the original? Okay, same thing here. What can I divide into 15 and 25, the biggest number? It's going to be a 5. So because we are factoring out the GCF, divide everything by that GCF. So 15 divided by 5 is 3, so 3k. 25 divided by 5 is 5. And notice again, I can't take out a k because I don't have a k over here. So distribute back. Do we get to the original? 5 times 3k is 15k. 5 times 5 is 25. Now C and D only have variables. Same thing. Just like what we did right here, find the smallest exponent. So y to the 7th plus y to the 5th, the smallest exponent is this y to the 5th. So, y to the 5th on the outside, and now divide everything by y to the 5th. This is why we spent time on our exponent rules. Y to the 7th divided by y to the 5th. When we divide, we subtract. So 7 minus 5 gives me 2. Now, be careful here. Y squared over y squared, those kind of cancel out, right? You got the same thing on top as you do on the bottom. If you close your parenthesis here, when you multiply back, do you get to the original? Well, y to the 5th times y squared gets me y to the 7th, but that's it. So even though these cancel out, you need that placeholder here of a plus 1. That way, now when I distribute, y 5th, y squared gives me y to the 7th, and y to the 5th times 1 now gives me y to the 5th. Okay, you have to have that as a placeholder. And so the best rule of thumb I can give you is if you have 2 terms here, you need 2 terms here in parentheses when you are done. Okay, same thing here. D to the 8th and d to the 5th. Smallest exponent is at d to the 5th. So divide everything by d to the 5th. So d to the 8th over d to the 5th is d cubed. You're subtracting 8 minus 5. And d to the 5th over d to the 5th, those cancel again, just like here. But we're not closing that because if I multiply, that only gives me d to the 8th. So what I need to do is have that minus 1 as that placeholder. I had 2 terms, so I need 2 terms still in parentheses. So now d to the 5th times d cubed is d to the 8th, and d to the 5th times that negative 1 gives me negative d to the 5th. So these last 4 have a combination now of number and variable. So far we've only had one or the other. So on E, what can I divide into 5 and 20? That is 5. And how many x's can I take out? I got an x to the 4th and just an x. So we're taking out the lowest one, which is an x. So now divide everything by your 5x. 5 divided by 5 cancel. X to the 4th divided by x, subtract, and we get x cubed. Negative 20 divided by 5 is negative 4. And x over x cancels each other out, so this is it. And distribute back, and you can check it. On F, what's the biggest number I can divide into 6 and 12? That is 6. Okay, and if you're not good with like the numbers that I'm picking, do your upside down birthday cake. Okay. What's the lowest exponent? We got x to the 5th and x squared. Or a to the 5th and a squared. So that's a squared. So now divide. My 6's here cancel. A to the 5th and a squared gives me a cubed. Negative 12 divided by 6 is a negative 2. And then my a squared and a squared cancel each other out. And again, distribute to check. Okay, now we got 3 terms, but that's still okay. And if you notice here, I do have a typo. Let's change this last a to a y. We do need to have all of the same variable there. All right. So, what can I divide into 9, 18, and 3? That is going to be 3. Now, up until this point, I've told you just to kind of ignore your signs. As a general rule of thumb, we always want this first term here to be positive. So because this is a negative, I'm going to take out a negative 3. Okay, all these other ones, these first terms were positive, so we took out positive GCFs. But because this first term is negative, I'm taking out a negative GCF. And then how many y's can I take out? What's my lowest exponent? Is that 1y here. Okay, I'm going to write this a little bit lower. Okay, so now divide everything by negative 3y. So negative 9 divided by negative 3 is 3. Y to the 5th over y is y to the 4th. 4 minus 1, or 5 minus 1. Negative 3y into the second term. So 18 divided by negative 3 is negative 6. Y squared and y become y. And then divide this one by negative 3. Well, my negative 3's cancel, my y's cancel. So do I just close this? Hopefully you said no. You've got 3 terms here. That means I need 3 terms in this parenthesis. So we're going to put plus 1 as that placeholder. So now when you distribute into this last term here, you get that minus 3y. Okay, and then last one. What can I divide into 8, 20, and 12? Okay, hopefully you said 4. Okay, and negative. It is negative because this first one here is negative. How many x's can I take out of everything? We got a squared, a cubed, and an x. Lowest one is at x. And how many y's? We've got a fourth, a cubed, and a cubed. Smallest one is that cubed. So now let's divide. Negative 8 divided by negative 4 is 2. X squared over x is x. And y to the fourth and y cubed, that's going to leave me with 1y. Divide here. Negative 20 divided by negative 4 is a plus 5. X cubed over x is x squared. And then y cubed and y cubed cancel out, so we have no y's there. And then my last one, divide. 12 divided by negative 4 is negative 3. And then my x's cancel and my y cubes cancel, so that's all we're left with. And what is an easy, quick way to check our work? Distribute it back. Okay, I don't know if you can tell, but that's a cubed right there. All right, guys, that's all I have for this lesson. Sorry it is so long, but this is split up into 2 lessons. So hopefully you're not sitting, in class for as long as we were in this video. Again, let me know if you have any questions. Pause this video, rewind it as much as you need.